Hey everyone, today we're going to kind of wrap up our conics, our discussion of conics. We're going to talk about a couple of different things. First thing I want to talk about is identifying a conic section without completing the square. So let me kind of backtrack first and then I'll get into this whole idea of how to do it without completing the square. You'll see on your sheet, on your note sheet in front of you, this box that's on the top of the screen here, you have on your note sheet, and then there's 4 different examples. What I want to do is I want to take one of those examples. I'm going to take actually example number 2. That example is x squared plus y squared plus 6x minus 2y is equal to 6. And we can easily enough determine what type of conic section this is simply by completing the square on both the x and the y and getting it into the standard form. Okay, so let me show you how we would do that. And we've done this before way back when we did circles, and then just recently when we've been doing these conic sections. But let me just give you a quick refresher of what I mean by that. If I were to complete the square, I'd have x squared plus 6x, I'm going to leave a space there, plus y squared minus 2y, and I'll leave a space there, is equal to 6. And then we say, let's complete the square on x, and then also complete the square on y. So I take half of 6, which is 3, and I square that, so that gives me 9. Whatever I add to one side of my equation, I have to add to the other side. And then I'm going to do the same thing with the y. So half of negative 2 is negative 1. If I square that, that's positive 1. Whatever I add to the left, I have to add to the right. So on the left here, I end up with x plus 3 squared plus y minus 1 squared is equal to 16. And if you see this, you just say, oh, that looks like an equation of a circle, right? We did that a long time ago, but we did do them, and that would be a circle with center negative 3, 1 with a radius of 4, because remember this represents the radius squared. Okay, now if we were to look at this just strictly as a conic section, because a circle is a type of conic section, remember that the right hand side of our equation is always in terms of 1. And so in order to do that, then I would have to divide everything by 16. And so I would end up with x plus 3 squared over 16 plus y minus 1 squared over 16 is equal to 1. And that is, in fact, a conic section. That's the standard form of a circle. Now, how do I know that it's a circle? Well, one way I know that it's a circle is because both of my coefficients here are exactly the same. Right? The coefficient for this left term is 1 over 16. The y term is also 1 over 16. It's just that you haven't been used to seeing it that way. You've been used to seeing circles, and again, we haven't talked about circles in a while, but you're used to seeing circles in this format here, where it's just written like this. But those two equations are equivalent. They're just different ways of writing it. Okay? Now, we also said with an ellipse that we also had x and y squared, right? There was a plus sign there. But there was something very specific about an ellipse. And an ellipse, our coefficients are not the same. Okay, but there is a plus sign, so they're both positive, and that would make it an ellipse. Right, so for example, if I had an ellipse, the equation of an ellipse might be something like x plus 1 squared over 4 plus y minus 7 squared over 9 is equal to 1, right? So they're both positive, but they have those different denominators, right? And one represents your a value, one represents your b value. we know that, or excuse me, this is a squared and b squared. Remember we said whatever the larger one is tells you what your major axis is. So because my larger value is under the y, that means my major axis is vertical, right? But still that's an ellipse, okay? Those numbers are different, but they have the same sign. They're both positive. And what makes something a hyperbola was when we had one of them had a minus sign. So you could have x plus 2 squared over 16 minus y minus 1 squared over 9 equals 1. Okay, that minus sign is what makes it a hyperbola. Now, if both denominators were the same, it would still be a hyperbola because of that subtraction sign, because one of these is positive and one of these is negative. Okay, so that's different than the circle over here. So that's how you would do all of that if you completed the square. However, we have a way to do it without completing the square. And what we do is we go to the general form of any conic section. And you'll see here that we have an x squared term, a y squared term, an x term, a y term, and a constant term. And you'll notice that there's no b value in here, and there's a reason for that, which we'll get into shortly, okay? But strictly, we're sticking to A, C, D, E, and F, okay? Now, you can do exactly what we just did without completing the square simply by just doing a couple of quick calculations, okay? So, for example, if A and C are equal to each other, then it's a circle, right? Like here, A and C were equal to each other. There's a 1 in front of the x squared, there's a 1 in front of the y squared. So they're both equal to each other. That would make it a circle. So you don't have to go through the process of completing the square to determine that. The next thing we look at is A times C. Well, if A times C is actually equal to 0, then it's a parabola. So let's think about that for a second. Remember, if it's a parabola, only one variable is squared. So if one of them is squared, that means the other one doesn't exist, which would mean either A or C was 0. Right? If there were no x squared term in our equation, then A would be 0. So A times C would be 0. So if A times C is 0, that means we have a parabola. It's also easy to tell if you have a parabola if only one of your variables is squared. Okay, but technically what you're doing is finding A times C. Okay, the next one is if A and C are not equal to each other, and A times C is positive, then it is an ellipse. So in this case, right, A is 1/4, C would be 1/9. 1/4 times 1/9 would be 1/36, which is greater than 0, so that's an ellipse. Now let me be clear, you don't have to calculate any of these when your equation is in standard form. Right? This right here is standard form, this right here is standard form, this right here is standard form. This is general form, and we're talking about when your equation is in general form, we can use these calculations to determine what type of conic section it is. Okay? And if A times C is less than 0, then it is a hyperbola. So let's go through the examples that are on your sheet. In example number 1, we've got 4x squared minus 25y squared minus 24x plus 250y minus 489 is equal to 0. Okay, so I'm going to look at my A and my C value. So my A value here is 4. My C value here is negative 25. So if I find A times C, that gives me negative 100. Since that's less than 0, that tells me that I have a hyperbola. Okay? That's all you have to do for those. Number 2 we just did. So I'm not going to go through that again. Number 3, if you just look at it, I'm not going to actually write it out, but if you just look at number 3 that's on your sheet, you'll see that y is the only variable that's squared. There is no x squared, which means that a is 0, which means that a times c is 0, which means it's a parabola. And if you look at number 4, 9 times 25 would give you 225. That's greater than 0. A and c are not the same, so that tells you it's an ellipse. Okay? So that's how you can go through identifying different types of conic sections. Okay, the next thing I want to talk to you about, and I'm going to just take a minute to talk about it with you right now, and then I'm going to stop the video, and then in the next video you'll see the work through of the problem. But it is a I do want to make sure I have enough time to work through the whole problem, so I'm just going to introduce it right here. Here's the idea. What happens is that all of the conic sections that we've done so far, we've dealt with horizontal axes, vertical axes, like major axis, minor axis, or your transverse axis, whichever conic section we were doing, that we always dealt with everything being vertical or horizontal. What we are going to do now is we're going to start rotating our axes. So if this is your x-axis, this is your y-axis, we rotate through an angle of theta, and now we are at x prime and y prime. And that's how we would name our new axes. Okay, so we're rotating through an angle of theta, and now we have these new axes. So for example, we might have an ellipse, right, that is now rotated, and how do we find the equation of that new ellipse? What we are going to use is we're going to use these formulas in order to take our new equation and rewrite it into a form that we're more familiar with. Okay, into the form of all the other conic sections that we've been working with. If you notice here, this is where that b term comes in, because if we have this bxy, we didn't have that before. If you see this in your equation, that is telling you, by having that term in there, that's telling you that the axes have been rotated. Okay, so that's how you know, without having a picture, just by looking at an equation, that's how you can tell what kind of, if your conic section has been rotated. And what we're going to do is we are going to use these equations to basically rewrite our, to transform our equation into a standard equation that we're more familiar with. Okay, so that's going to be coming up at the next video, and we'll catch you back here in a couple minutes. Thanks, guys.